my speakers on the dais, esteemed audience. Really, I'm the second last speaker between you and the lunch. I'll try to finish at the earliest. The point is that I fully agree with the chairman that he talked about the decentralization, which is the key word, and at the same time it is commercial viability. Because scalability is a subjective term, which sometimes it may work, it may not work. But two things are essential. One is the decentralized things, and another is that commercial viability. If two things exist simultaneously, I will have a focus on, with these 2 points, I will have focus in my presentation. This cavitation techniques nowadays from last 3 to 4 years has played a very important role. Next slide, please. Yeah, these are the points which I am going to cover, and a couple of things I may skip. Next one. Next slide, please. Yeah. Normally, cavitation, as a mechanical engineer, we say that this is a harmful thing. It erodes the materials and other things. And likewise, I have taught 10 to 20 years, 2 decades, I have taught how to avoid the cavitation. But that was only one side of the coin. The other side of the coin is that controlled cavitation play a very, very important role in and more positive aspects as far as the applications are concerned. So I'll focus more on that side of the coin. Next one. Basically, ultrasound or sonication, it play a very important role in chemical reactions. Most of the chemical reactions, normally they use the mechanical stir, where hours and hours you mix the things, and then finally the reaction takes place. And once you have hours and hours in the reaction, the point is that time consumption is high, catalyst consumption is high, lot of drawbacks in the process. But if instead of this one, if the mixing is done by using ultrasound, it is much, much faster as compared to the conventional techniques. What are the reaction which takes place in hours, that can be converted into minutes, and that is also true in the case of fuel, whether it is a biodiesel, whether it is ethanol, or whether it is a biogas. Everywhere these kind of reactions play an important role. I will not go much details, but the point is that these techniques are developing very fast, and almost you can say the commercial applicability is also industry is going to achieve. Next one. Yeah. Sorochemical effects, already you can say applications are there, but the main point is that mechanism point of view, the origin of the bubbles, then continuously compression, expansion of the bubbles, and finally collapse of the bubbles. And due to these reasons, what happens? The mixing takes place very fast, and all the conventional drawbacks of mechanical strings that can be removed. And based upon that one, we have also considered in our laboratory we have done the experiment, and we have seen that these techniques can play a very important role in development of fuel and its commercialization. The next one. Next. Yeah. This is a typical slide where almost can say everything is taking place macroscopically at atmospheric conditions. But when you do these cavitation conditions at microscopic level, the temperatures and pressure conditions are very high. And due to that reason, what happens? The radicals are formed, and these radicals and redox, they substitute the catalyst, so that reaction becomes very fast. So this mechanism, still you can say the research is going on. But the point is that this play a very important role in developing a system, because the industry wants the pressure and temperature conditions less stringent as compared to the requirement. From that point of view, in extraction techniques, in mixing techniques, or any reaction where A plus B becomes C plus D, this is the knowledge available from last 100 years. But how to make it efficient through technological point of view, from that point of view, these techniques can enhance the technology, and at the same time, reduction in time, and energy efficient and less time consuming, and at the same time it will improve the commercial viability. Next slide, please. Yeah, this is a typical example of, you can say, biofuel, where transifixation reaction takes place, and due to that one, this transifixation reaction normally in conventional reactors it takes hours and hours, whereas in the case of this ultrasound mechanism, in terms of minutes one can achieve. Next one. Yeah. Now the point is that there is criticism. Normally, my science friends work in the area of this ultrasound, and they use a small sample. They say that the mechanism is very wonderful, other things. The moment it comes to the application in the industry, the point is that commercial viability and at the same time the scalability. From that point of view, the same concept, if the proof of concept is developed at ultrasound, then the same concept we can go for hydrodynamic cavitation using this particular diagram, where through the pump we can just abstract the solution, pass it through orifice or a venturi, which can be scalable easily, and then the same argument which we have developed in the case of ultrasound, in that case we can develop it. And further, the scalability is very good in this aspect. And based upon this one, we have developed a plant also. Next slide. Next slide, please. Yeah. Another important point is this. Yes, some of the data are there. I'll just tell you quickly. Move forward. Yeah. In that case, yes, the main, I will just compare that. If you compare the mechanical stirring, then the point is that it is 5 times higher reaction rates, 5 times less reaction time, and 6.5 times higher energy efficiency. Of course, the concept-wise, equipment-wise, it is not a rocket science. But this technique is play a very important role as far as the efficiency is concerned. Plus, at the same time, the equipment will become very compact as compared to the conventional one. Next one. Another technology, I'm talking about the commercial viability point of view. So once we have developed the concept of ultrasound in the laboratory, then how to do the scalability point of view. This first was the non-rotating, and this one is a rotating technique where the 2 concentric cylinders are there. Inside is a rotating cylinder which is having the blind holes. And whenever around say 3000 RPM, when the inside cylinder rotates, then what happens? Through that one, due to cavitation phenomena, microjets comes in the form of just like a missile, and almost you can say mixing becomes very, very fast. Within 10 minutes, you can get a reaction. Even this technique has a wide range of role in case of food technology, in case of you can say biotechnology, and non-fuel applications also. And particularly petroleum industry is also using this technique for preparation of a lubricant at the site. Next slide, please. Yeah. So normally, can say in our laboratory, we have started with ultrasound. We have tried with various types of seeds and other things and achieved very good results. That was the first step. We have developed the proof of concept, and based upon the proof of concept, we have developed this next one. Yeah, these are the calculations we have done for development of plant. And next one. Yeah, this was the 100-liter plant we have developed based upon the hydrodynamic cavitation. In the literature, people have developed only up to 10 liters and 15 liters, but this is a very compact one, and almost what we can develop from 500 to 1000 liters conventional size, the same thing we can achieve it because the time requirement will be less and fast, can say due to the fast reaction, the very compact plant equivalent to a very big size as compared to mechanical stirring. So from that point of view, Cell Energy and Professor Vijay is here. So he was instrumental in can say developing this plant, and from Cell India has given us a fund for this one, and almost in the last week we have demonstrated this particular plant. Next one. Yeah, this is a typical diagram of that plant, a very compact size, and at the same time, as per the European standards, the yield must be more than 96.5. So we have achieved 98.5. So from that point of view, all the commercial standards we can maintain, and we have got very good results. And this can be almost, you can say, integrated with the rural technology, and the farmer, or even this technology can be can say implemented by semi-skilled laborers. That is the main feature of this technology. Next one. Yeah. The point is that these are the salient features. I will not go in details, but almost comparing all the safety aspects as well as the commercial requirement point of view, we have achieved that one with less consumption of energy, less time, and saving in the catalyst. Next one. Yeah, I will not go through this one. Next one. Yeah. The point is that these are the technologies which play a very important role, and this is the technology we have also developed in the laboratory, and through rotating cylinder also we have achieved also good results. And we can see that some of the oils are very, very high FFA content, and we know that when FFA content is high, it's difficult to convert into biodiesel. So first, we have reduced this FFA content using this technology in minutes, whereas in conventional technology, it requires hours. Next one. Yeah, these are some of the other people who have worked in that area, and results are available. Next one. Yeah. Even now, I'm coming out this. I talked about the biodiesel. In case of these techniques, they can be applied as a pre-treatment process in the case of alcohol production, because these techniques, from cellulose and hemicellulose, that can be separated from lignin very fast if you use these pre-treatment techniques. Next one. This is a typical 150 this alcohol plant developed by Italy, and similar type of small plants can also be thought in our country also. Just like biodiesel plant, we have done it in a similar way. Normally, in the case of ethanol, a big size is required, but even a small scale can play a very important role. Next one. Yeah, these are the process. What the reason is that why can say this is efficient technology. Number of steps are drastically reduced as compared to that one. So that is the main motto of that one. We know that in alcohol, boiling and other things are required, but in case of this cavitation technology, drastically many steps are merged and number of steps are reduced, and the technology almost the final product will match with that one. Next one. Yeah, yeah. So another is that last one I will just tell about that one. This is a conventional biogas plant where we can get the biogas, but if we retrofit this device of this hydrodynamic cavitation, in that case, not only the quantity will be increased, but at the same time, quality of the biogas will also be improved. So this techniques can play an important role, and the number of days required to get the biogas, that can also be reduced. So from that point of view, the techniques which we have developed, they can be applied in the case of fuel. Particularly 3 fuels are important. Biodiesel, it's important. These techniques we have tried for that one. In the same time, in ethanol production, pre-treatment, we can use these techniques, and at the same time, in biogas also, to increase the production as well as quality of production. In both the cases, all these techniques play important role. So I will stop at this point because there are a number of non-fuel applications are also there, but the time is short. I will not cover that one. Thank you very much, sir.